So, hi Professor, this is Li Zhong. In this video, I'm going to talk about three things. The first is inverse demand function or inverse demand system. I'm going to talk about how, like, the basic idea of it, and I'll also do like a very simple example to show how we can get it. And I guess this example is also a good one for you if you ever want to explain it to your students. And second, I will talk about the welfare measures in inverse demand system, namely the equivalence variation, compensated variation, and also deadweight loss, which is measured by Michaelian surplus. So this is like the second half of Kim's paper, actually. So last but not least, I will go back and talk about Feng and He. I will actually challenge the ground of this paper, specifically to the endogeneity problem. Okay, and so, let's start. I will first talk about how Kim is presented like the inverse demand system in his paper, but that is not like a very intuitive one. Anyway, I will start from there. So first we have like a basic setup. It looks exactly the same in the direct demand system. So it's like we have a utility function, which is defined like this. It's based on the quantity of goods that we're going to consume, and that determines the level of utility. And also we will have like a budget constraint. I will denote it as M. Okay, so with this, we can do two things. The normal way we're gonna approach is to solve the optimization problem, and by that we can get direct demand function of any goods. But apparently, Hotelling and Vold has proposed like an identity, and Kim used this identity, go directly from here to derive inverse demand. This is quite complicated, it's presented in the paper, but I don't think it matters a lot here. It's just like a way to go through the original setup like to the inverse demand system. Actually, it can also be obtained by reorganizing the direct demand function. So let's define the direct demand function as this. So it should be a xi. This is the quantity of a goods with some level of prices. And then reorganize it, we will get our inverse demand function. Or in another way, this can be also obtained from another setup. Namely, we will now define a new utility function. Actually, it's the inverse utility, which is defined by the level of price and also the same budget constraint. Solving again the optimization problem gives us inverse demand. I will show it why this is the case later in my simple example, but in Kim's paper, it can also be obtained from this setup, that the direct demand function by Royle's identity. So this is like the simple layout of the first part of Kim's paper. It shows the duality between the demand function and the inverse demand function. And I will show this duality like empirically, not actually empirically, mathematically from our basic example. Now, let's jump to the example. I will, again, do the simple setup. Now, I will use Cobb-Douglas utility function here and define it as this. So there are only two goods in this market. And then the budget constraint will look like this. So I'm using like alphabets to represent the actual level of prices in this market because I want to obtain this form so as to show so as to echo like the form I propose here. But that doesn't matter. You can always use like a real number representing P1 and P2. That wouldn't matter. And okay, so with this, the normal approach is to solve the direct demand function. We will just do that. And the way of doing that, like there are multiple ways of doing that. And here I will use Lagrangian it would be a good way to show the duality as well. So the Lagrangian setup would be I'm gonna use K here, but you can also use lambda, it doesn't matter. To solve the maximization problem of this, so we'll need to take partial derivative. So I'm gonna put a max here. Partial derivative against x1, partial derivative against x2, and against k. This is x2 square plus p1k 0. P2k goes to 0, and here just rewrite this part and don't ignore the negative sign here, so it would now become something like this. I'm gonna I wouldn't show the way like how we actually solve this, but it's very simple. I'm just gonna directly jump to the results, which it gives us like I said before, the direct demand function, which is x1 now rearrange it, we will get the inverse demand function. Well, thanks to the special Cobb-Douglas functions, they'll look quite similar to each other. So just like looking in a mirror, this is the direct, this is the inverse demand. Or we can also solve it by using the inverse inverse utility function. But the way we get the inverse utility function is by substituting this back to the original utility function. Now we will have like a new setup and put a v here. This is times 2 over p2 square, and the budget constraint remains unchanged. Again, solve the optimization problem. But now let's note that the interpretation would be slightly different here, because now the base of the function is the price, and intuitively in such a market we are actually, so the quantity are unchanged, like the quantity are given, in other words, are exogenous. So the way to maximize the utility is actually to obtain the minimal prices. This is like in opposed. This is the opposite of the left-hand side, because here we are trying to maximize the quantity. So in a given level of budget, we want as much as goods as possible so as to maximize our utility. But here, with a given like budget, we wanted to minimize the price we need to pay. So this is like the slightly but interesting difference. Now it becomes, the problem is like this. Still, I'm gonna use lambda here just to distinguish it from the left-hand side. Again, solve the optimization problem require us to take the partial derivative here. So, sorry, this is over P1. Then this is basically plus, this is basically the same thing. So lambda equals to 0. Partial derivative against P2 gives us plus px2 lambda equals to 0, and partial derivative against lambda give us the same thing here. Solve it. We will get, believe it or not, you can try it yourself. I've already tried it. It will give us exactly this. So basically, they're the same. So this is like the basic idea of the inverse demand system. It's just like I said before, looking in a mirror of the direct demand. And this is also like a simple version of Kim's paper of how to get this.